I like the warning that your author gives right up front with verifying trig identities, because most students confuse solving or verifying trig identities. They get that mixed up with solving trig equations. When you're asked to solve an equation, you are allowed to add, subtract, multiply, and divide both sides by stuff to try to get the variable by itself. You're not doing that with identities. Why? Because you don't even know if what we're starting out with is a true statement or not. I don't know. I'm trying to show that the left side and the right side are the same thing, which then would allow us to add, subtract, multiply, and divide, right? So we want to try to show that for all values of s, the left side and the right side are the same. And here is my personal advice to you guys when verifying trig identities. You always start with the more complicated looking side. You try to make it look like the easier looking side. So if you were to compare the left side and the right side, right, of this identity, clearly you would say the right side looks more complicated. So let's start with that. I'm going to recopy the right-hand side. Right-hand side says cosecant s times the quantity cosine s plus sine s. And it's our job to transform that using nothing more than those fundamental identities on the first page. Try to make this look like the other side. Now, things that you can do. You're allowed to use distributive property. That's fine, which is what I'm going to do first. And you're also allowed to multiply top and bottom of a fraction by the same thing. Because you're not adding it to both sides or anything. You're just simply changing what a fraction looks like. It's like taking 1/2, right, and simply rewriting it as 6/12. Nothing wrong with doing something like that. So let's use the distributive property and see what happens here. We would get cosecant s times cosine s plus cosecant s times sine s. And what I'm going to do now, folks, is take the two cosecants and remind myself, what are those equal to? Cosecant's the same thing as 1 over sine. 1 over sine s times cosine s plus 1 over sine s times sine s. Now talk to me what happens on the left part. Well, 1 over sine s times cosine s. That gives you cosine s over sine s. And cosine divided by sine is cotangent. What happens over here? What happens when I multiply those together? Sine over sine ends up being 1. And you are finished. You have made the left side look like the right side.
Okay, I kind of lost the last part. 1 over sine.
1 over sine times cosine over 1 is simply cosine s over sine s,
Okay.
and that gives you cotangent.
Okay.
I'm going to warn you about identities right now. You can't tell just by looking at it if it's going to be difficult or not. Okay? My advice to you guys, again, personally, is always start with the more complicated side. Try to make it look like the easier side. You will have problems where both sides look like they have equal difficulty. So what do I start? You pick one. Pick the left. Try to make it look like the right, and if you run into a brick wall or you don't know what to do next, go the other direction. You're not going to always get these the first time through the problems. I guarantee it. I guarantee it. Let's try another one. Verify the following. Again, I'll leave it up to you. Which side do you think we should start with?
Left.
We'll start with the left. So we have tangent squared x times the quantity 1 plus cotangent squared x. And we're going to try to make this look like the right-hand side. I assume we'll end up starting using distributive property,
Well,
or not.
would it be easier just to make it into tangent squared x times cosecant squared x?
Why do you say that?
Well, I don't know. I'm asking you.
Why are you saying that? You're telling me that right here sits an identity.
Yeah.
Oh. Let's take a look at that.
I hate you.
He's saying, hey, 1 plus cotangent squared x is the same thing as secant squared x. Now notice where we're headed, right? We're headed to an expression that has just a sign in it. So my advice to you, change everything as much as possible to sines and cosines. It's a lot easier to work with sines and cosines than it is cosecants, secants, and cotangents. So we know that tangent squared. What happened?
Nothing.
Oh, we know that tangent squared is sine squared over cosine squared, right?
How you get square 1 plus cos square theta equal cosecant square? Yeah. 1 plus cotangent square.
Cotangent squared plus 1's cosecant squared.
Yes.
Oh, I'm sorry. Did I not hear you right?
Maybe. I might have said it wrong.
This needs to be a cosecant.
It's Monday.
Yeah, that's.
When he starts looking around funny, I know something's wrong. We're okay because you caught it right before I was getting ready to write the next fraction. Cosecant squared is 1 over sine squared. Okay. Don't know where this is headed, but let's keep going. When we multiply those two fractions together, looks like we're going to end up with 1 over cosine squared, right? Because the sine squareds would cancel each other out. And cosine squared, according to Pythagorean identity, if sine squared plus cosine squared is 1, then cosine squared is 1 minus sine squared. Excellent. You're done. There's your other side.
Cosine square.
Questions there? Let's make them increasingly a little bit more difficult as we move on. Or at least they look difficult. Directions say again, verify that the following is an identity. Man, I don't know. What do you think? Start with the left, start with the right.
I say start with the right.
I'll go left again.
Right. Look easier.
You don't want to start with the easier looking side. It's a lot easier to make the hard side look easy than make the easy side look more difficult.
But I think the hard side.
Let's see what happens here on the left. And there's a reason why I want you to start on the left. One tool or technique that seems to help with a lot of identities is if you have a sum or a difference in the numerator, like we do right here, break it up into individual fractions. So this would be the same thing as tangent t over sine t cosine t minus cotangent t over sine t cosine t. Right? Again, let me show you what I did there in terms of an algebraic statement. We all know that x plus 2 over 3 is the same thing as x over 3 plus 2 over 3. That's all we did with this problem, right? We took that sum or difference in the numerator, broke it up into two separate fractions. Now take a look at what happens to each fraction. Tangent t is the same as sine divided by cosine. So up top, we have sine t over cosine t, all of that over sine t cosine t, minus the numerator of this fraction is cosine divided by sine. Cosine t over sine t divided by the same denominator. And now what's going to happen to each one of these fractions? Well, sine over cosine, that's the numerator. If you're going to divide that by sine t cosine t, that's the same as multiplying by 1 over that. So what happens is, what cancels out?
Cosine.
Now watch out.
Both.
We're going to take sine, let me show you again what's going to happen here. We're going to take sine t over cosine t, that's the numerator. And we're going to multiply it by 1 over sine t cosine t. Do you see what happens? These disappear, and we're left with 1 over what? 1 over cosine squared. Same thing's going to happen over here on the right-hand side, but in this case, our cosines cancel out, and we're left with 1 over sine squared t. And then our final step, folks, look where we're headed here. We can use our reciprocal rules. What's the reciprocal of cosine? Secant squared. Or reciprocal of 1 over cosine squared is secant squared. And the reciprocal of 1 over sine squared is cosecant squared. And there's your other side. Now, I don't want you to get a false sense of, oh, okay, I start with one side, I get through this, I get the other side. I kind of already know what I want to do with these problems because I worked them out ahead of time about a day ago. Now, if I would have just throw a random trig identity up here for all of us to work on, I might not know which side to start on. We might start on one direction, get to a place where we just don't know what to do next, so we would have to try it in the other direction. Okay? Here's one that I recommend, or I want to show you. Here's one where it's not quite clear which side you might want to start with. I mean, if you compare the left-hand side to the right-hand side, they look the same. However, I see that with the right-hand side, I could possibly break it up into those two fractions. I could have 1 over cosine plus sine over cosine. Will that get me anywhere? Sine over cosine's tangent. I don't see any tangents on the other side. I don't know. What do you think?
Well, see, that'd be easier again, right? It's the known route, so we can left again.
I'm sorry.
If you can break it up into two fractions and we know that worked to the last one, wouldn't that be the easier side again? So then you start with the other side?
Not all the time. Not all the time. You're trying to look ahead to see where you're headed. 1 over cosine, what's that going to give me? 1 over cosine is going to give me secant. I don't got any of those on the other side. And sine over cosine is going to give me tangent. I don't got any of those on the other side. Let's start with the left-hand side, and I'll introduce another trick up your sleeve that you may decide to use.
Break it up.
What's that?
Can you break it up?
I told you you have the option of multiplying top and bottom by the same thing. So if my denominator is 1 minus sine x, let's try multiplying top and bottom by 1 plus sine x. You guys remember that in algebra we called multiplying by the conjugate? So let's see what we would end up with. Up top, don't be in a big hurry to use distributive property. Up top, right, we're going to have cosine x times the quantity 1 plus sine x. Hey, look at the numerator of where I'm headed. Oh, 1 plus sine x. I got that. Let's keep going. What happens in the denominator? What is 1 minus sine x times 1 plus sine x? Don't forget algebra. What is 3 minus x times 3 plus x? You might remember it as factoring difference of squares. We'll go in the other direction, right? 1 minus sine x times 1 plus sine x is 1 minus sine squared x. Again, if that's not quite clear to you, do you remember how to factor the difference of squares? If you go this way, you'll see where it's coming from. 1 squared is 1, and sine x squared is sine squared x. So over here sits the sum and the difference of the two things being squared. Well, wait a minute. What's my denominator the same thing as? We have cosine x times 1 plus sine x. Denominator can be rewritten as what? What's 1 minus sine squared the same thing as? Cosine
X.
cosine squared x. Cosine squared x. So I have cosine times cosine in the bottom. I got one cosine up top. That cosine cancels out one of those cosines, and I have 1 plus sine x over cosine x, which is the other side.
See, it looks so easy when you do it.
You know why? Because I did them ahead of time.
I know, but I just cut this kind of problem before, so hard.
Now I picked 2 homework problems at random that you guys are going to work on in a group for extra credit. I haven't even done them yet. So we'll work on those together today. That's if you're interested in extra credit. I mean,
like that, or extra
have I ever given that yet?
No,
Yeah, I didn't think I did.
you should do that every class.
I don't have time.
You make time.
I'm going to go ahead and I want to give you enough time to do some extra credit, but I want you just to take this problem and go ahead with it.
This is part of extra credit too.
So I took each, I notice over here we're only dealing with sines and cosines, right? So I took the left side and started by simply changing everything to sines and cosines. Secant is the same thing as 1 over cosine. Tangent, sine over cosine. Secant again, 1 over cosine. Tangent again, sine over cosine. And look at that. Common denominator. Common denominator. So we can put those fractions together, right? Common denominator is cosine alpha. Add the numerators together. Down in the denominator, common denominator is cosine alpha. 1 minus cosine alpha is the numerator. And now you guys know that a fraction divided by another fraction is the same thing as the top fraction times the reciprocal. Therefore, your cosine alphas are going to cancel each other out, and you're left with what's in blue. With me on that? Dividing by this fraction is the same as multiplying by the reciprocal. Cosines alphas cancel out. Now you have what's in blue. Now the next step in red is I multiplied top and bottom by the same thing. I multiplied top and bottom by 1 plus sine alpha. I kind of peeked and looked ahead as to where I'm supposed to end up. The only way take a look at the numerator of what you're supposed to end up with. A very good question. The numerator is, let me write it up here the numerator of where we're headed is sine squared alpha plus 2 sine alpha plus 1. Now, when I stare at that at first, nothing jumps out at me. Look at it in terms of something you're familiar with. Instead of sine alpha, what if it just would have been x? This is the same thing as x squared plus 2x plus 1. Right? That's all that is.
Yeah.
And when you factor that, you get x plus 1 times x plus 1. Which is why, then to go in the other direction, I chose to multiply by the same thing as the numerator. And then I crossed my fingers to hope that the denominator pans out. So 1 plus sine alpha times 1 plus sine alpha gives you the numerator. And now when you multiply denominator together, right, 1 minus sine alpha times 1 plus sine alpha, when you first, outside, inside, last, and FOIL all that, you get 1 minus sine squared. And 1 minus sine squared is the same thing as cosine squared.
You're only gonna have one of these problems on the test.
1 or 2. Yeah.
One would be awesome.
None would
Actually,
be
zero,
zero.
but
Now, going in the other direction, let me just show you something. You would start here. Obviously, you would see, hopefully, cosine squared, you'd have to change to 1 minus sine squared. Okay? Now, to go from that step to the next one, you'd have to factor. You'd recognize this as being difference of squares. So there's where you get this guy times this guy. Up top, you'd recognize it like the polynomial that I just showed you, right? At least you'd get this far. You know, here's what you would have going in the other direction. And right there is where I got stuck, because I had no idea to, as if by magic, take where I'm at and change it into that. Just something you cannot see ahead of time. You just don't know to write it that way. That's what made the other direction more challenging.
well, I didn't do.
Okay.
Screwed that one up. I broke it up.